we have a flashing blue LED that we're setting via digital pin out 3. We're turning it on and off, and we're doing so at 2 Hertz. So it's on for about 250 milliseconds, then off for 250 milliseconds, then on for 250 milliseconds, and off, and so on. We can set the frequency with which we turn this on and off via this potentiometer that I have right here. So we can quicken this, so we'll increase the frequency, and then we'll watch what the waveform looks like on the oscilloscope. So now you can see on the screen I've set it to 4 Hertz, and we'll see, indeed, you can see the frequency increasing on the oscilloscope, and it actually does some analysis, some signal analysis, and it tells us that the frequency of the waveform that's coming out of that digital output pin 3 is 4 Hertz. Let's keep going. Now we've increased it to about 7 Hertz, which means that the wave period is about 0.14 seconds. So it'll be on for about 71 milliseconds, and then off for 71 milliseconds. And sure enough, the oscilloscope says that it's running at 7 Hertz. Let's go up, see if we can get to around 10. Okay, now this is around 10. So the wave period here is 100 milliseconds, where the frequency is 10 Hertz, which we can see here. Let's keep going all the way. 13 Hertz, 14, 17, 18, 19. This is 20. And so that is the actual output of digital pin 3. Hey, so I modified the program. Before it was going from 1 to 20, so 1 to 20 Hertz. Now I've set the maximum to 100, and we're still at the maximum on our potentiometer. And we can see, obviously, there is a much higher frequency waveform on our oscilloscope, and that it's analyzed it to be about 100 Hertz. So we're outputting about 100 Hertz. We can open up the serial monitor as well to see that. And we can also change the resolution on this. So we sort of zoom in onto that waveform. So now every one of those dotted lines is spaced by 10 milliseconds. And so the full period of our waveform is 10 milliseconds because we're at 100 frequency, 100 Hertz frequency. Now we can slow it down. And notice how with persistence of vision we can't actually really tell that the LED is blinking. I don't know how it's being picked up on the camera. Now we're going down to 50 Hertz and the LED still looks like it's just persistently on. So I hooked up the oscilloscope to the output of pin 3 because I wanted you to start building a mental model for what the microcontroller is doing when it turns on and off a pin, when it sets a pin high and low. In this case, we're using delays to look at setting various frequencies for that output pin. And if you set the on for 100 milliseconds, then off for 100 milliseconds, and on, then off for 100 milliseconds, that's going to turn the light on and off 5 times per second, or at 5 Hertz. In fact, we can see that on the oscilloscope. The delay is 100 milliseconds on, 100 milliseconds off, 100 milliseconds on, 100 milliseconds off, and that's for a wave period of 200 milliseconds, or 5 Hertz. And we get to see that exact thing on the oscilloscope. This is graphing the voltage output of pin 3. So hopefully this has been useful to you in advancing your understanding of what's actually happening on the digital output pin as we're starting to use delays and thinking about modulating the voltage output on these digital output pins.